All right, 8.3 geometric sequences. So this stands for the nth term, just like before. And then this n still stands for the term number, just like before. And those things stay in the formula just as they are. But what you need to find this time, the easiest thing to find for geometric sequences is the first term and then the common ratio. So you just find a sub 1, which is the first term, and you plug it in for a sub 1, and then you find r, which is what you're always multiplying by to go to the next term, and that's called the common ratio. And if you want to find that, the easy way to find it is just divide any two consecutive terms, and then you'll know what you're multiplying by, right? Because division is the opposite of multiplication. So we'll do that in a second. So let's try this. First, let's verify that this is a geometric sequence. So what do you get when you do 15 divided by 3? 5, right? 75 divided by 15? 5. 375 divided by 75? 5, right? So we verified it is a geometric sequence. With r, so r, you could take any two consecutive terms, like say 375 over 75, any two, and it's going to be r. That's your common ratio. And then what's the first term? Is 3. So we're ready to write our formula, just like that. So it would be a sub n equals the first term, which is 3, times the common ratio of 5. And it's always raised to the n minus 1 power. And that would be it. So let's see why it's to the n minus 1. So like if you want the first term, what does the exponent become? N minus 1. 0, right? And so do you see how this just goes away? 5 to the 0 power is just 1. And so you're left with your first term. When you plug in n is 1, this times 5 becomes times 1, and we just get the first term. And then 2, you're multiplying 3 by 5 once. 3, you're multiplying 3 by 5 twice. 4, you're multiplying 3 by 5 3 times, etc. So hopefully that formula makes sense. It makes it easy to remember if it makes sense. So let's see. Let's say we have the sixth term in the common ratio. So we already know the common ratio, so we'll put that in our formula. But we're given the sixth term. How are we going to find the first term? So what you can do is, to find the first term, you take the negative 96. Since we know the common ratio, how many times do you think we have to divide by 2?
6.
So it's actually 5 times, because we're not doing the 0th, right? Last time we did the 0th term. We just want to go to the first term. And let me show you an easy way to always figure out how many times you do something. You basically just take the term number, so that's the sixth term, and you want the first term, and you just subtract. So you would do 6 minus 1 is 5. So whenever you want to go from one term to the next, just subtract the term numbers, and that tells you how many times you have to do something. So this 5 comes from doing 6 minus 1. From the sixth term to the first term, you would do something 5 times. But it's, of course, the opposite. We don't want to multiply, we want to divide. So if we back that up, 2 to the 5th is, you can do this on your calculator or in your head, 32 is 2 to the 5th. And then divide that, and you get, the first term is negative 3. Yeah. So any questions on how I found the first term? By backing up from the sixth term? Okay, so we're ready. A sub n equals the first term, which is negative 3. And then use parentheses for multiplication, times 2 to the n minus 1. It's always to the n minus 1. The a sub n and the n minus 1 stay the same. And we could double check. If we plug in 1 for our first term, that's to the 0 power. 2 to the 0 power is 1 times negative 3 is negative 3, which is what we had. But we could try it with 6. If you plug 6 in here, you should get negative 96. Okay, now what about given any two terms? So the first thing we need to do is find R, what's happening with R, find the common ratio. And so we know to go from the second term, so we know a sub 2 is negative 12. Here's like a sub 3, we don't know. And here's a sub 4. This is what we're given. If you were to look at it visually, that the second term is, we know the second and the fourth. So how would we find what we're multiplying R? How do we find R? Well, if we want to go from negative 12 to negative 3, how many times do we multiply by R? To move from here to here? Twice, right? So that would be times R, and then moving again would be times R, right? Twice. So basically, that's R squared. And that gets you to negative 3. So what I'm doing is I'm writing an equation for myself to solve for R. Let me make sure solving the equation is easy, but let me make sure the equation makes sense. So if I did like a separate problem, let's say I had like a sub 7 equals 1 and a sub 30 equals 89. Let's set that up. This is like a separate little problem. So you would say 1 times R, how many times? 30 minus 7, right?
Oh.
23 equals 89. So this would be our common ratio. It would be like the 23rd root of, because I just made this up. But so you basically, to figure out what R is, take the term numbers and subtract. 30 minus 7 is 23. You're starting with 1, going to 89. So that was just a separate problem. You don't have to write that down. Just want to make sure it's clear. So now let's solve this equation. So we do what first? To solve for R? Yeah, get rid of all the stuff around it that's easy to get rid of. So we get R squared is, that's basically positive 1/4. And then to undo R squared, we take the square root. So R equals 1/2. Square root of 1 over square root of 4 is 1/2. So we know R, and now we still need the first term. So to find the first term, we start with, say, the second term, right? And we have to back up 1. So instead of multiplying by our common ratio, we divide by our common ratio. So the first term is?
Negative 24.
Yeah, negative 24. So now we're ready to write our formula. So we have a sub n, the nth term equals the first term, negative 24, times 1/2 the common ratio raised to the n minus 1 power. So that is that.